Good afternoon, everyone. My name is Andrew Fisher. These gentlemen are Ron Powell, Mark Heller, Nick White, Robert Marshall, and Tyus Lund. The problem we are looking to solve is near and dear to our hearts, student and faculty safety on campus. To facilitate this issue, we are designing a distributed real-time optical data analysis system.
The overall consensus among the majority of the student body is that the campus is not as secure as it could be. Police work tends to be reactive, and even implementations such as the blue emergency beacons assume a best case scenario where when the victim presses the button, the police arrive and the suspect is still within visibility, which is now a reasonable expectation.
The next day emphasized that we will be focusing on decreasing the response time for law enforcement to arrive to the scene. Less suspects equals less crime for a safer environment.
So currently, a typical scenario would be the following. A crime is committed, the police is notified either via the emergency beacons or a distress phone call, and then the police arrives. However, by the time the police arrives, there'll be probably multiple people at the scene. They won't know which one's the suspect, and likely the suspect will be far away from the scene.
So the proposed solution for us is to implement something that already exists. The technology exists, but it's very limited. Currently, as you see in the video here, the video has to be pre-recorded and it can only come from one camera at a time. The system we want to implement is going to be for multiple targets, and it's going to be using multiple cameras, which hasn't been done before. We also want to develop object and gesture recognition, which is going to allow this system to be proactive in determining when a crime is about to happen. We're going to do this by deploying a distributed Internet of Things system, which is going to be connected to a server or a cluster of servers. So our system contains some inputs and some outputs, and as you see here, none of these things are new. These are technologies that are already being implemented, but what is new is the sum of all these technologies, where the whole is going to be greater than the sum of its parts. This middle section here is going to be what we're implementing, which is connecting all these technologies together. A typical use case, as you saw before, would look something like this. With our system added, it would look something like this. Right off the bat, there's more visibility. Similar to before, when a crime happens, that person in the red is the criminal. As they go to get away, as they did in the current state, they would be ID'd by the system. As they go to move between cameras, they would be tracked in real time, and they would be passed from camera to camera, which would alert the police real time where that person is and where they're headed. A sample mobile app would look something like this for law enforcement, where in the bottom left you have a current feed, which is going to be displayed in real time with people actively tagged. In the bottom right would be a map displaying where all the suspects who were in that area were at the time and where the police is, and also the current status of the operation.
So currently, this project is facing a few challenges. First is that coverage is limited to only the land that CSU owns, so we only have access to the cameras that CSU owns and operates, which is a very small chunk of what Cleveland actually is. The second problem is that camera coverage needs to be close to overlapping. If a suspect moves from one camera to another, we can track them within those two cameras, but if they're somewhere in between, we really have no idea where they are. Third problem is that all these systems that are already in place require human activation. In order to track them, we need some way to know that an event happened, which is either calling 911, pressing one of the security beacons. Right now, we have a reactive system, but we'd like to make this system a proactive system.
So the ability to track an object across multiple cameras is valuable in many industries. While the current use of this system will be for monitoring criminal activity, it can be applied to any object that has physical characteristics that we can predict. The sort of data collection and monitoring can obviously be used for governmental and military uses. Some less obvious uses will be universities, private security, Fortune 500 companies, industry, wildlife, and home use.
So we'll start with our research phase, in which we will learn how to use and implement the open source, completely free computer vision software. Then after our first semester presentation, we will begin building and testing our prototype and using the data from that to optimize the object tracking methods for our system. And from there, we will present our final presentation with our final model. And here is a more in-depth Gantt chart of the research, development, and implementation phases.
One of the big problems we're trying to solve is that currently large industries, large corporations, as well as the government agencies like the FBI and CIA, they have huge research and development budgets. So they have the latest and greatest, best and brightest. They're working on things, which leaves campus police and local police with the hand-me-downs. And we thought this was odd, considering some of the best and brightest, latest and greatest are right here in this building. So we want to leverage the engineers here in order to create a technology that would better how we experience things on campus. Thank you.
Thank you.
Nice job.